Okay, good morning, everybody. This is Mr. Taylor, and what I want to talk to you about briefly in this PLC is multiple representation. Now, according to the National Council on Teaching Mathematics, as mathematics teachers in the middle grades, we have to find an approach to teach these algebraic concepts that that is explicit about the importance of how these students learn and how they represented quantitative relationship, uh, what they should and should not be able to do. But according to NCTM, students should have the ability to graph. They should have the ability to use tables. They should have the ability to use words or create words from what they see, and definitely must have the ability to symbolize what they see with an algebraic equation. So we have to be able to make this lesson and all lessons on algebra accessible to students, uh, especially those that I teach, the that we teach in this population, which is the underserved or the on level students. These are the students that probably will have issues. Maybe could be at risk, could be uh, ELL, inner city, but we have to be able to move these students as well as the pre-AP and the Algebra 1, 7th, and 8th grade students. So what I want to do is talk to you about uh, how I address my students when we have a certain situation, when we have a problem. And what I attempt not to do is give them a problem where all they doing is looking and solving. So I try to make the problem where it's real world, where they can actually see the problem, describe the problem in detail, and then what I do once I get the problem up, I pose questions intentional to the students so they can understand what they're looking for and how to work from there. So again, we want to teach these students how we represent what we see more than one ways. Okay, so let's say for instance that we have a situation that says, well, you guys got $10 to spend. You got $10 to spend. You can either buy a $2 Hershey bar and a $1 Tootsie Roll, uh, but you can't get any change. So what I'm asking them to do is create a way where they can literally buy all chocolate, and out of the $10 they can get no change, just completely. And let's take into consideration that this is probably somebody at school selling, and we're not looking at the tax approach. Okay, so we've given them the problem. You have $10 to spend on $2 Hershey bars and $1 Tootsie Roll. How many ways can you spend all of your money without receiving change? This is the situation. So what I expect for these students to do is to be able to go through this particular problem and see, well, I have 10. The Hershey's are $2 each. Tootsie Roll Pops are $1 each. So I need to spend all of this money. I'm not going to get no money back. So I need to spend all of this money. Okay. So in order for me to spend all of this money, I got to come up with a way. And I always tell them, now once you've looked at the problem, create a table. Create a table, and you can start this table any way you like. But in this particular situation, they got a chance to look at the number of Hershey bars first, and then they looked at, okay, well, what about if I insert the $1 Tootsie Roll Pop? So these students were able to know that if I have 10 dollars, and each Hershey bar is $2. So I can divide 2 into 10, and I can get 5 Hershey bars, and well, no Tootsie Roll. Now, in essence, if I wanted to buy all Tootsie Rolls, they are $1 each. So I divide 1 into 10, and I can buy 10 Tootsie Rolls and no Hershey bars. So that's the top, the two extremes, and the top and the lower. So it's pretty easy for them to come up with that. But in the middle sector is where they struggle just a little bit. Well, if we take, starting with the Hershey bars, we bought 5. Well, let's reduce 1 and buy 4. What about if we bought 3? What about if we bought 2? What about if we bought 1? And then what if we bought 0? So if we bought 4 $2 Hershey bars, we're going to spend $8. Well, we got $2 left. So, of course, we can buy 2 $1 Tootsie Rolls, and we've spent $2. And, of course, 8 plus 2 gives us our total $10. Well, let's take, for instance, if we want to buy 3 $2 Hershey bars. Well, 3 times 2 is 6, but we got $4 left. Well, in essence, we can buy 4 $1 Tootsie Rolls, and there's our $4. So 6 plus 4 gives us the 10. So we're still doing well. Well, 2. What about if I've only bought 2 Hershey bars? Well, 2 times 2 is 4, and I have $6 left. Well, again, I can buy 6 $1 Tootsie Rolls, and there's my $6. And, of course, 6 plus 4 is the 10 that I'm allocated to spend. Well, if I only want 1 Hershey bar, well, 1 times 2 is 2, and I have $8 left, so I can buy 8 Tootsie Rolls. 8 times 1 is 8, and then $8 plus $2 is $10. And, of course, we talked about if we didn't want any Hershey bars, we could just spend all our money on the Tootsie Rolls. So that gives them, or they were able to create a pretty decent table to justify how they would spend their money and how much they, no change, and how much chocolate they would buy. So after that, we had to take a look at what it would look like to graph this particular situation. Okay, if we're going to graph the situation, okay, now we can take this same information that we looked at previously, we can take this same information and the actual students did, and we can create a graph. Now, what I always let my students, and I always tell my students, that we're dealing with a real world situation. So if we are dealing with a real world situation, then we only going to use quadrant 1. And quadrant 1 tells us that both X and Y is positive. So as we're looking at this particular graph, then we're just going to look at, realistically, again, the number of Tootsie Rolls compared to the number of Hershey bars. So again, if we look at our graph, our increments are Hershey bars 1, 2, 3, 4, and 5, and then 6. And then here, our Tootsie Rolls are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, the students struggle a little bit trying to figure out which one would go Y and which one would go X, and how can I change my increments. But they quickly found out that the price would be the increment. Since there's $1, then if we bought 1, it's only $1. If we bought 2, it's 2. And this is counting for the Tootsie Roll Pops. And then these are $2 each. So you get another segment, another interval as far as the actual prices. So they were able to look at that. If we're looking at the very first ordered pair that we created when we were looking at the formula, we said that we were going to buy 10, I believe. Yeah, we said that we would buy actually 5. We said we could buy at $2 each. We could buy 5 Hershey bars, and we could buy, if that's the case, we would get no Tootsie Rolls. So that's going to give us an ordered pair of 5, 0. Then we said if we wanted to buy only Tootsie Rolls, then we could buy 10 of them and no Hershey's. So they were able to go on and graph this thing as 8 and 1, or they could buy 6 and 2, or 4 and 3, or 2 and 4, and of course buy 5 and no Tootsie Roll Pops. So they were able to analyze this graph and know that this graph, and literally, let me explain that they were quick to point out that the graph was discrete because they knew that they were talking about objects, people, places, or objects. We always know that that's a discrete graph. And then they were able to go in and connect with a trend line. But the only thing that they did understand that these are discrete points because we wasn't breaking the candies in half. We were buying individual pieces. So that was a good thing that they were able to understand that, and it really made me feel good as a teacher. Well, after they were able to get the graph, then they was charged with creating an equation. So as they looked at the actual equation and what they were going to do to create the equation, they knew that they had to do something with slope, because we had to first find out, according to what we were looking at, and if we were looking at an equation, we were looking at y is equal to mx plus b. So we have to find out what is m, and we also have to find out what is b. So they knew that b is the y-intercept, so they were able to come up with here 0, 10 is that particular point. But as they went on, then they just took 2 pairs, and what I like about it is they didn't really confuse themselves. They just took the ordered pair 0, 10 as y1, x1, and y1, and then they went down and took the ordered pair 5, 0, and they used that as x2 and y2. So the first thing they did was created slope. And by doing the actual subtraction, they were able to find slope using what we just put here as negative 10 over 5, which is simplifies to negative 2. Then, of course, they used 10 as the y-intercept, and in the form of a line, y equals mx plus b, they came up with the equation negative 2x plus 10. So these students were able to see this thing more than one way. They were able to see it as a problem, as actually words. They were able to see it in the table, and then from the table they were able to see it by graphing it from the table, and then they were able to see it in the equation. So regardless of how we present it, they could see multiple ways of solving the problems, or multiple ways of getting the correct answer. And this is the way we must teach these students, especially in this middle grade. And I think if we do so, we can be successful. So, hey guys, I appreciate you taking the time this morning and spending with me. And if you have any questions, please let me know now. Thank you.